Welcome back. So in this lesson, we're going to put together the previous two lessons that we've done in order to fully graph these rational functions. All right, so be ready to write a lot down. Again, it's piecing together quite a few things. So it's all going to be doable because we've already shown you can do these skills, but now is putting it all together. Now, the beginning of all these problems is going to look like exactly what we did at the end of the previous notes. We're going to factor, cancel, find the asymptotes or holes, and then I'm going to show you how to create a graph from this. All right, so step one is to factor. So I'm going to factor the top, and I'm going to factor the bottom. Or sorry, factor the top, and then factor the bottom. And if you look at this, nothing is going to end up canceling out in the end. None of the pieces actually end up being the same. So a little bit strange situation, but it can happen that even when you factor, sometimes nothing's going to cancel. So that's going to leave me with 2 points of discontinuity there and there. Now I want you to notice neither point of discontinuity canceled out. Okay? So that means I don't have any holes, but I do have 2 vertical asymptotes, one at -2 and one at 2. So I'm going to plot those right away. A horizontal or vertical asymptote at -2 and one at -2. All right? So I'm just going to plot my 2 vertical asymptotes right there. Now, in terms of my horizontal asymptotes are from the degree. Well, here we don't really like looking at factored form, okay? So if stuff had canceled off, that would be different. But I never taught you how to look at horizontal asymptote from factored form. So since nothing canceled, our function is still basically the original function. So I'm going to go back and I'm going to keep looking at the original because again, nothing canceled, so it is still the same as the original. So I'm going to compare that. Degree 2 over degree 2, well, that's our same over same case. So that means we need to take the ratio of those leading coefficients. So 1 over 1 is going to put our horizontal asymptote at 1. So I'm going to put that on here too. A horizontal line at 1. So before I have to worry about points or anything, I should have all of that taken care of. Holes, vertical asymptote, horizontal asymptote, okay? All of that should be taken care of. Now, the neat thing here is I'm going to let you use your calculator to finish the rest. So let me show you how to use the calculator to do this. So you can go into the graphing feature. All right, so turn on your calculator, go into the graphing feature, and I'm going to graph this function. Now, again, since nothing canceled out, I don't really want to type in factored form to my calculator. So because nothing canceled, we're still talking about the same function as the original. So the original is what I'm going to type in, making sure I use parentheses around the top. So x squared plus x minus 12 and putting parentheses on the bottom, x squared minus 4. So I type that into my graph, or I type that into my y equals, and now I'm going to graph this. And that is what my graph is going to look like. Okay? So, with that being my graph, I do want to get just a couple points to look at. All right, a couple points that I'm going to be able to graph and look at. So here, I'm going to take this negative 4, 0, 0, 3, and 3, 0. Okay, I'm going to write those down. So negative 4, 0, 0, 3, 3, 0. Okay, so I'm going to take just those couple points just so I have some accurate starting points when I'm sketching it. Okay, and again, where did that come from? Well, I went second graph, and that's how you get to the table. So once you see the general shape, I want you to go just grab a couple points for me. Once you have those points, that's all you need, and now you can just sketch the rest. All right, I don't expect it to be perfect. I don't need a ton of points. I just want you to have those couple points just so you know approximately where it should be. And then you use a calculator to simply sketch the rest of it. Okay? So let's look at this process a couple more times. We have 2 more examples we're going to work through just so you can see precisely how this works. So let's move on to our next example. Again, the key, we're always going to be factoring. So we have x plus 3. Let's look at this. X minus 2, or whoops. X minus 5, x minus 1. So here we have 2 points of discontinuity, one at 5 and one at 1. And again, notice, nothing canceled out here, okay? So because nothing canceled, what that means is both of them are going to be vertical asymptotes. We're not going to have any holes in this situation. So let me just plot these. Right, and now horizontal asymptote. Well, again, if nothing canceled out, we don't really know how to look at factored form. And so since nothing canceled, it's basically the same as the original. So I have a degree 1 over degree 2. So that is a less over more situation. Less over more, remember, automatically means it's put at 0. So I need to draw your horizontal asymptote at 0. And now that we have all of that finished, okay, now that we have that, now we can go look at the general shape, get the calculator to give us a couple points, and then we can move on. So let's go back to our calculator. I'm going to go back to y equals. I'm going to clear out that function that I just had put in, okay? I'm going to clear it out, and I'm going to put our new function. Again, being careful, I need parentheses around the top, so x plus 3 divided by, and then parentheses around the bottom, x squared minus 6x plus 5. Now I'm going to graph it to see the general shape. All right, so here's my shape of this one, okay? But again, just to be as accurate as possible, I am going to go and get a couple points. You get points from the table. So second graph will get me into that table. So I'm just going to choose just a couple points that I can use so I can be as accurate as possible in my graphing. So I'm going to choose -3, 0. I'm going to choose, let's see here, 3, -1.5. And I'm going to choose, oh, no, there won't be any better points. So 6, 1.8. Okay, so I'm going to look at each of those. So then 3, -1.5, 6, 1.8. So just take those couple points, and then I'm going to sketch the curve. So just to remind you what that curve looked like, it's looking like that. Then that. And then like that. Okay? So again, you don't have to know the shape yourself. All you have to do is be able to sketch what the calculator is giving you. So let's do one last example, and then you can go and work on your practice work. So factor the top and bottom. So here we have x minus 2, x plus 1. Here we have x plus 5, x minus 2. So now we can see the cancellations happening. So now we can see those. And what we end up with is x plus 1 over x plus 5. And we're getting here a discontinuity at -5 and a discontinuity at 2. Remember, the one that cancels means that there's a hole at x equals 2 and a vertical asymptote at x equals -5. So I can show that vertical asymptote, 1, 2, 3, 4, 5. I can show that vertical asymptote. We're going to come back to the hole later. Okay, that's something that we're going to deal with later because right now we don't know where that hole exists except the x coordinate. Horizontal asymptote. Now, because there were cancellations, now I don't have any parentheses left in my function. So I can actually use my new function to compare the degrees. I just can't have there be any factored form, but here it canceled out, so my form looks nicer. So I can actually use my newest form. When you do that, you get the same over same case, degree 1 over degree 1, when you compare the new function. So compare the coefficients, 1 divided by 1. I have my horizontal asymptote at 1. And now I can take that, now I can look at the general shape. And again, because there were actual cancellations here, I can go back to y equals, clear that out. Because I had some actual cancellations, I can actually use my current function. So that x plus 1 divided by x plus 5. I can actually use that because, again, there's no factored form left. It canceled, left me a nice function. So that's what I'm going to plug into my calculator. So you could say that's my general shape, all right? So now I want just a few points just to see where we're looking at. And I'm going to go close. So see that error? That error means that's where my asymptote is. All right, so I'm just going to take a point on the left, point on the right, basically just like we did when we were graphing before. That's what I've been doing, just picking points around the asymptote. So I get negative 6, 5. And negative 4, negative 3. Wait, did I write that down wrong? No, okay. So negative 6, 1, 2, 3, 4, 5, 6, 5, 1, 2, 3, 4, 5, and negative 4, negative 3. And then I can sketch it in. Now the one thing you might be wondering about is I haven't dealt with that hole yet. So for that hole, what I want you to do is where x is 2, so x is going to be 2 along that line there. So I want you to see at the point that the graph is on x equals 2. For the hole, I just want you to put a little open circle there. That little open circle, that is meaning that every point on the graph is there except that one little point, okay? So that's what we need to do for the holes, is just indicate that one little point is missing. That is the only point on the graph that is just missing. It's removed. But you do have to note that for me, okay? So wherever you see a hole, you have to just put a little open circle wherever that x value is, okay? So again, I apologize that this video got a little bit longer, but there's a lot of stuff going on in this notes. So please make sure you absolutely must have all of that written down, and then please come and see me if you have any questions. I know that there's a lot happening, and then we'll get you going on your practice work.